Hi, this is lesson 2.5. In this lesson, you guys will be learning about transformation. What we're going to be doing is we're going to look at the graph of the basic functions, and then we're going to perform transformations on them. That means we're going to move the graph up and down, left and right, stretch it vertically, stretch it horizontally, or flip it over the x-axis, or flip it over the y-axis. So before we do those transformations, we want to be able to identify what the parent functions, the graph of the parent function looks like. And you want to be very, very good at identify these the graph of the parent functions by heart. So before we are able to learn it by heart, it's good to understand how the graph of each functions comes to be by plotting these points. All right, so let's start off with graphing the constant function f of x equals 0. So f of x is the same thing as y, so let's write y equals 0. This means all the values of y are going to be 0. Y is always 0, regardless of what x is. And we're going to pick some x values to find the y values. Preferably, if possible, we want to pick some negative values, a 0, and some positive values. So let's start picking a negative 2 for x. And again, because y is always going to be 0 for this function, y is going to be 0 regardless of what the input is. So now let's plot the point, negative 2, 0, negative 1, 0, 0, 0, 1, 0, 2, 0. So again, every single x value is going to have an output of 0 for y. So the graph looks something like this. And you can imagine if we were to transform it, we can move it up and down, left and right. And imagine how it would look like if we were to reflect it over the x-axis or the y-axis. Now let's go over to the next function, the linear function f of x equals x. This is a very basic linear function, y equals x. So this means the x and the y values are going to be the same. If x is negative 2, the y value is also negative 2. X is negative 1, y is negative 1. X is 0, y is 0. X is 1, y is 1. X is 2, y is 2. Now plot these points, negative 2, negative 2, negative 2. Negative 1, negative 1, 0, 0, 1, 1, 2, 2. And this is a linear function. We're going to draw a line through this. All right, next we have the quadratic function. This is one of the popular functions as well. Let's pick some points. Negative 2, if we plug in negative 2 in there, y equals a negative 2 squared will give us a positive 4. Plug in a negative 1, y equals negative 1 squared, that gives us a positive 1. If you can do this in your head, put in the 0, 0 squared, 0. 1, 1 squared is going to be 1. 2, 2 squared is going to be 4. Plot the points, negative 2, 4. Negative 1, 1, 0, 0, 1, 1, 2, 4, and then draw the graph going through these points. So this is what the graph of a quadratic function looks like. It's kind of like a U. And again, we will be performing transformation. That means we may be flipping it over the x-axis or moving it up and down, left and right. Yeah. All right, next, let's look at the cubic function. F of x equals x cubed. So if we plug in x is negative 2, then negative 2 times negative 2 times negative 2, that would be negative 8. So the output would be negative 8. Input in negative 1, the output would be a negative 1. Input is 0, 0 to the third power is going to be 0. Input 1, 1 to the third power is going to be 1. 2 to the third power is going to be 8. Plot these points, negative 2, negative 8. Negative 8 is probably somewhere down here. And then negative 1, 0, 0, 1, 1, 2, positive 8. It's going to be somewhere up here. So the graph looks something like this. Next, let's take a look at the absolute value function. If we input a negative 2 for x, the absolute value of a negative 2 is going to be a positive 2. Input a negative 1, the absolute value of a negative 1 is going to be a positive 1. absolute value of 0, 0, absolute value of 1 is positive 1, absolute value of 2 is going to be 2. Plot these points, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Connect the dots. The graph looks like a V shape. Next, we have the square root function. F of x equals the square root of x. Now remember that for a square root function, everything that's inside the square root has to be greater than or equal to 0. So the domain is x is greater than or equal to 0, or starting from 0 to infinity. So that means we cannot input a negative value into the square root of x. The square root of negative 1, for say, is going to be not a real number. It's an imaginary number. So we're going to ignore that D and E. So what we want to do is pick values that are within the domain of square root of x. So let's start with 0. The square root of 0 is going to be 0. The square root of 1 is going to be 1. And then we want to pick values that we can easily take the square root of. If we were to pick the value of 2, we don't really know what the square root of 2 is. We just know that's 1 point something. But we can't really pinpoint where that is on the coordinate plane exactly. So we want to pick x value that's easy for us to evaluate, right? Pick x equals 4. The square root of 4 is 2. The square root of 9 is 3. So now let's plot these points: 0, 0, 1, 1, 4, 2, 9, 3, and then connect the dots. So this is what the graph of a square root function looks like. Next, we have the reciprocal function. F of x equals 1 over x. So if we input a negative 2 into x, we end up with a negative 1/2. For y, if we plug in a negative 1 into x, we end up with a negative 1 for y. If we plug in a 0, we can't have a 0 in the denominator, so that point doesn't exist. If we plug in a 1, y equals 1 over 1, which is 1. Plug in a 2, 1 over 2. Now let's plot these points: negative 2, negative 1/2. Negative 1, oh, by the way, this should be negative 1 here. Negative 1, negative 1. 0, we can't plot the point there because the input 0 doesn't give us an output. And recall that for the domain, for fractions, x cannot be 0. Next, we have the point 1, comma 1, and then 2, comma 1/2. Now, imagine this. We don't have to write these out. But if we were to put in a 3 in here, if the x is 3, then we end up with a 1/3. If x is 4, we end up with a 1/4. If x is 5, we end up with a 1/5, right? So the graph would go down like this, but it would never get to 0. If we plug in a 1,000 for x, then we end up with a 1 over 1,000th, right? Now, let's see what happens if we were to plug in a decimal value. Let's say x equals 1/2. 1 over 1/2 is the same thing as same thing as 1 times the reciprocal of 1 over 2, which is 2 over 1. And that would give us a 2. So if we plug in x equals 1/2, the y value is going to be 2. And you can kind of see if we were to plug in x equals 1/3, 1 over 1/3 is going to give us 1 times 3, which is 3. So if we plug in a 1/3, we end up with a 3 for the y values, 1/4, a 4 for the y value, 1/5, 5 for the y value. So the graph looks something like this. Okay. Similarly, on this side of the coordinate plane, if we were to pick x equals a negative 1/2, then the y value is going to be 1 over negative 1/2, which is 1 times a negative 2, which is a negative 2. So negative 1/2, negative 2. And then similarly for if we were to pick x equals negative 1/3, negative 1/3, 3, negative 1/4, negative 1/3, negative 3, negative 1/4, negative 4, and so forth. So the graph looks something like this. getting very, very close to the y-axis. And if we were to pick x equals -3 and plug into the function, x is -3, y is going to be -1/3. X equals -4, y is going to be -1/4, x equals 5, y equals -1/5. So we can see the graph looks something like this. So for the reciprocal function, we have the graph that looks like this. We can naturally draw this line right here where the graph is kind of go towards 2, but it's not crossing that line. This is called the asymptote. And we also have another asymptote right here. So the graph is going towards that line, but it's not crossing it. All right, next we're going to discuss about the greatest integer functions. This is something very different and very new to you guys. So we're going to save this for another video.